Welcome to Study Loop.
Question 64 asks, a rock released from rest to fall on a small airless planet falls y equals gt squared meters in t seconds and g is a constant. And it reaches 20 meters below in t equals 4 seconds. So part A has to find the g value, and this can really be simply done by substituting what we know. So what we're given is y equals gt squared. We know that at t equals 4 seconds, and I'm going to put this in red, at 4 seconds, we are at 20 meters. Therefore, this is 4 times 4 is 16, 16g. I'm going to write up here. 20 divided by 16 is equal to g. And when we simplify, we are going to get 5 over 4 as our g constant right here. Part B asks to find the average speed for the fall. And we did this in an earlier problem, but we're going to do it again. And again, to find the average speed, we are going to do change of y over change of t. And we know that we want to find the y at 4 seconds. Therefore, we are going to take the formula that we do know, which is y is equal to 5 over 4 t squared. And this time we do know g, so we are going to substitute g as 5 over 4, which is just equal to 1.25. And going back up here, we have 1 minus 1.25. And the other time that we do know, and the height that we do know at the time, is 0 seconds. So on the bottom is a change of time, which is just 4 minus 0. And when you put this into the calculator, you're going to get 20 in the numerator divided by 4 in the denominator. Therefore, the average speed for the fall is 5 meters per second. Oh, sorry. I wrote feet for some reason. Make sure your units are always correct. It's very different. It should be 5 meters per second. Part C asks, with what speed did the rock hit the bottom? So first, when did the rock hit the bottom? The rock hit the bottom at t equals 4 seconds. What we want to find is the instantaneous velocity or instantaneous speed. And we know that to find the instantaneous velocity, we want to consider a time slightly after t equals 4 seconds. So we're going to put 4 plus h as our second final time. And again, we're going to still use change of y over change of t. However, this time, instead of substituting 4 like we did in part B, we are going to substitute the final time, which is 4 plus h. So let's do like so. So this is final minus initial divided by the change in time. Again, the final minus initial. It's need a couple more pages, but when you expand the numerator out, it'll be 16 plus 8h plus h squared minus 20 divided by, I'm going to use red to indicate some of the cancel outs. 4 is canceled out by this negative 4. Therefore, we only have h on the bottom. We're going to keep solving this through. So when we multiply this through, it'll be just 20 plus 10h plus 1.25 h squared minus 20 divided by h. Again, let's do some cancellations. 20 with negative 20, h with this h, and h squared becomes just h. So now let us go to another page to finally figure out what is our speed. So the limit as h approaches 0, and using this, what we found right here, 10 plus 1.25 h is really just 10 feet oh, not feet, 10 meters per second. And this is our time when the rock, this is not our time, this is our velocity with what the speed that the rock hit the bottom, 10 meters per second.